If you're using ChatGPT or Claude or Gemini on a daily basis, you'll probably be typing in the prompts. What if you could use your voice to generate the prompt? And so in this video, I'm going to show you how you could build your very own voice agent in Python with Assembly AI. And so if this sounds like fun, keep on watching. And without further ado, let's dive in. All right, and so let's get started. So the first thing that you want to do is head over to the GitHub repository that I've created for Assembly AI. So it's provided here at github.com/dataprofessor/assembly AI. You'll probably notice that there's several videos in the repository here. We had previously 4 Jupyter notebooks that you could clone, and this one will be the voice agent.py. So we're going to create the voice agent. And so let's have a look at the code. So you're going to notice that it has 212 lines of code here. And then for your convenience, we've already created all of the relevant classes that you're going to use, which will be in modular form. And then we're going to create specific functions that will allow you to stop the transcription, close the transcription service, and then it will process the transcribed text. So when I've heard that Assembly AI is going to release a new and improved streaming service, I was super excited in that it is now possible for us to create our own voice agent. Literally your own. So you could add custom feature, you could add delays to the code. Delay in the sense that whenever you talk, it will have a delay. And then during that delay, the Assembly AI library will perform the transcription. So to say, it's doing a live transcription while you talk. So that's the great thing. And it will be able to transcribe the text from both sides. If you're interviewing a guest on your podcast, it will recognize the different speaker and it will generate the 2 separate transcriptions for you because it has already identified the speaker owing to the different voices of the different speaker. So yeah, super exciting updates. And if you're going to PyPy, and then let's have a look. You're going to notice that there were several recent updates. And if I remember correctly, 0412 provided the ability to have new and improved streaming capabilities. Or it might have been June 2nd version here. But nevertheless, there has already been released, 4 subsequent releases that will improve the transcription functionality. All right, and so let's have a quick look at the code, and then we're going to take a look at the actual voice agent. So the first 10 lines, we are essentially importing the necessary libraries. And I'm going to show you, how you could literally install these on your own local computer. Then lines 13, 14, we're setting our API keys. And then we're having error handling for the situation where if it's not able to detect the API key, what it would do, right? And then we're setting the API key for Assembly AI right here. Line 23, the exit phrase is power off, meaning that whenever you're having a conversation with your own voice agent that we built, if you say power off, it will perform the shutdown of the voice script. So that's super cool. I'll show you that in just a moment. And yeah. A pointy note is that the class here, AI Voice Agent, was repurposed from Smita Colon. And yeah, she generously shared her GitHub repository on her own version of the voice agent. All right, so yeah, so the prompt that we're using is right here. So the prompt is, you are an interviewer for a role in data science. Can you be proactive in asking questions to see if candidate is a good fit for the role? Or the voice agent script is an interviewer. And yeah, we're going to simulate like a data science interview. And you are the candidate. So here are additional instructions like keeping your answers concise, ideally under 300 characters, generate only text and no emoji, because whenever it generates emoji, there will be some issue with reading it out. Please start by asking a welcoming question. Please ask only one question at a time, because sometimes, the generated answer will have might have multiple questions at the same time. So we're limiting it to only one. And typically it also adds, like formatting, like asterisk for bold. And if it does, then it'll make reading it a little bit awkward, right? It'll say asterisk, asterisk, instead of, like having the text bold. So yeah, we're just kind of like eliminating that, especially the case for when there is like a bullet point. So yeah, we're limiting that as well. And aside from being an interviewer, you could also experiment with other, like prompts, like being a coach for data science or Python, or even being an English language learning assistant. So yeah, I've actually tried that with my daughter and she really likes it. So lines 45 until 59 here, this will be the relevant function for starting the transcription. And we will print out listening. So whenever you see listening in the script, it's your turn to speak. And the settings that we've provided here that will be sent to the Assembly AI transcription service, it will generate a sample rate of 16,000. And then we have assigned the on data, on error, on open, and on close so that it will be able to perform the relevant transcription and open and close the transcription service as needed. And we also included the error handling for the start transcription. And in a similar fashion, when it detects that the real-time audio transcription is live, it will stop the transcription whenever it has detected that there is a silent period. And then it will reset the objects. Yeah, so here are additional callback functions that we've designed here. And when the LLM or large language model has generated a response, it will then be sent somewhere down here. It is worthy to note that for the user part, when you already have spoken during the listening period that I've mentioned earlier on, it will take the spoken audio and then it will upload that to the Assembly AI server. And then that will be transcribed. And then after transcription, it will then be sent to the large language model for response generation. So after the response generation of the large language model, it will then have the generated text be sent for generating the audio. So the text to speech part. Okay, so I'm going to show you that in just a moment. Yeah, so we have all of the relevant callback functions for the on error, the on close, as mentioned earlier on, that we've defined here in the transcription service part of real-time transcriber. So the core of the transcription will be here, line 76 until 89, where when it detects a pause, it will send the partial transcript for transcription. And it will perform the relevant or necessary text handling. It will lower the characters, and then it will perform the stop transcription service when you say power off, right, for this block of code. So it has the exit phrase right here. Whenever you say power off, it will, print out exiting on user command. And now we have the generate speech from the given text using Replica's TTS model, text to speech model. So for the Assembly AI part, we are taking the spoken audio from the user, which is you, and then take that audio to perform transcription. Once transcription has been complete, as already mentioned, it will be sent to the LLM for response generation. This is equivalent to when you type in the text into the text box and then you press on submit. So instead of the text that you type in, it's the audio that you speak out. And once the response generation has been generated, it will be essentially text, right? So you're going to take that text and then you're going to generate the speech. And for the speech generation, the text to speech generation, or TTS, we are using Replicate for that. So here we are using the Minimax model. So it's the speech 02 turbo, and we are setting the bitrate to be 32,000, the channel to be mono, and the emotion to be happy. And you also have the option to set other emotions as well, like happy, sad, angry, fearful, disgusted, or surprised, right? You could even provide this based on the sentiment. So if you add like a sentiment layer on top, like if you evaluate the sentiment of what is being generated, from the AI side, you could add the relevant tonality or emotion to your code. So I'll leave that up to you for experimenting. And for the voice ID, there are several speakers for you to choose from. So here, I'm going to leave it here as the default, and we're setting the sample rate to be 32,000. Okay, so we have additional error handling here and here. So here is the function for stopping the transcription, where it adds the user transcript to the history, similar to how when we do it when we are creating a chatbot. And for the LLM, we're using a local version. So we're not using OpenAI or hosted version. You're going to essentially install Ollama onto your own computer, and then you're going to use the local version. So in order to make speed for the local LLM generation to be faster, we're going to limit the model to be the small version. We're going to use the 1B version. So that will make the LLM response generation much quicker. And then this block of code here is essentially similar to how when you're going to build a chatbot, you're going to have to, iterate through the stream of the text chunk of the LLM response generation outputs. So here we're going to do just that. And so when we are generating the sentence from the spoken audio, we are limiting the characters to 300, right? And here it's detecting from the code for any punctuations which might signify the ending of a sentence, right? So we have the period, we have the question mark, we have the exclamation mark, or even the new line. So this is where you could, adjust the parameters. As I've already mentioned earlier on, when you have a pause in the audio or a pause when you are speaking, the user is speaking has a pause, it will generate a partial transcript, meaning that the pause will signify a full stop or a sentence with a period. So you could, essentially modify the parameters here so that it will generate, it will have longer pauses for you as it generates the, the partial transcripts. And so same for here, it processes and generates speech for any remaining text in the buffer after the sentence has been processed. And then here it finalizes the AI response, adds it to chat history, and begins the listening process all over again. Okay, so similar to how you would define in a chatbot, the row and the assistant and the final response. And then you're going to add that to the chat history. And the start function here is the main loop of the AI voice agent that we're creating. And essentially, whenever you start your script, it will print out the text as shown here, starting AI voice agent. And then we're going to sleep for 10 seconds here, and it will begin. And worthy to note that it also provides the instruction for you to say the exit phrase, which is power off if you want to exit. And it has the error handling here. If you press the Control C or Command C, you're going to be able to exit the script. And then finally, lines 205 to 212, we have the main function condition here. So it will start the voice agent, and it also has the corresponding error handling. So all of here in 212 lines of code, you are able to create your own voice agents. So let me show you the voice agent that we're creating. All right, so let me see, TWD, that's where we are right now. So I'm going to enter our working directory. And this is our working directory, voice agent, increase the font size a bit. All right, so we're gonna run it, Python. But before running it, we're gonna activate the Conda environment that we created for this. Conda activate assembly AI. And then let's see if we could run it. Okay, so it's asking for the relevant key. So we're gonna source the bash profile, and then we're gonna activate it again. Gonna activate assembly AI. So here we're typing in source and then the tilde symbol followed by /bash_profile so that it will activate whatever is in the bash profile, which contains the API token, the one for replicate and the one for assembly AI. I'm going to show you how you could create one. All right, and now we're gonna type in run voice agent. by doing Python voice agent.py, enter hello. So it might take a while to initialize when you first run it.
Welcome. Let's start with a quick question. Equal 1. What types of data are you most comfortable working with? 2. Describe a time you used data to solve a problem. What was the problem and what was the solution?
I'm comfortable working with structured data. And a previous time when I use machine learning.
Okay, that's good to know. Can you give me a brief example of a structured data type you've used?
Well, it is a data structure.
What tools did you primarily use for that project?
Great question. The structured data that I used was pertaining to a bioinformatics.
1. What database system did you utilize? 2. What programming languages did you employ?
Well, a simple CSV file and also just plain Python.
1. Could you describe the data structure within the CSV file? 2. How did you handle any data cleaning or transformation steps?
Well, the CSV file is essentially a comma-separated value, and for data cleaning, used pandas.
1. What specific cleaning tasks did you perform in pandas?
Okay. So you'll see that it has generated questions with numbered. So I guess we could modify that in the prompt. And you'll see that whenever you provide your answer, it will generate the relevant next questions related to what you have answered. And yeah, this would be a pretty cool tool to, like to revise for exams, for example. You could prompt it to help you when you study, right? You could even add additional context that will make it more robust in asking questions. You could even prompt it, add additional prompt instructions. So I think this is pretty cool. And let's see if you want to, whenever you want to modify any specific sections of the prompt, you could just modify the script here. And there you go. And a point to note here is that if you use simpler prompts and if you optimize the prompt, you'll be able to have better response, meaning that the AI will ask better questions. And you could play around with the parameters that I've already mentioned in order to, improve the gap between whatever you have spoken and the partial transcript that it will generate. And yeah, a caveat here is that you'll need internet connection because you're going to essentially use the assembly AI service for the transcription. And for the Olama, that is essentially local. So that's the LLM response being generated on your own local computer. So yeah, feel free to experiment with this and let me know what awesome projects that you're built with this. Perhaps you want to create a call center agent that will be able to speak to the caller, or, several other interesting use case like a live tutor, an AI tutor to help you revise for your exam, or, countless other use cases. And so let me know in the comment section down below what awesome projects that you're building. All right, and so now that we've seen how the voice agent works, we're going to see how you could essentially install this on your own local computer. So let's clear all of the instructions here, and let's go with installing the prerequisite library. So you want to search for Ollama. So go to ollama.com, and then you want to download a version into your local computer. So select the version that corresponds to whatever operating system that you're using. So I'm using a Mac, so I downloaded the Mac OS, and it will be in the download folder, and just install it into your own local computer. Once you install it, if you go to the command line and type Ollama, you should be able to see this. Okay, if you don't, it means that you haven't installed it yet. So go back and download and install it. And I'm going to show you how you could download the 1B version of Gemini. So we're typing in Ollama pool Gemma 3 and then colon 1B, and then type in and then hit on enter. And then it will download this into your computer. So you see that it has already downloaded this. That was fairly quick because I have already previously downloaded, and it has a local version of it already. So there are several other Ollama LLM models that you could try out. And because different LLM will have like different style of response generation, it might be interesting to see how your voice agent kind of pans out using different large language models. So yeah, I'll leave that as your homework to try out. And once you've downloaded the Ollama model, then you want to set the API token that I've already mentioned. So what we're going to do is you can go to assemblyai.com, or the link that I'll provide to you in the video description. So once you click on the link to sign up for Assembly AI in the video description, you'll be taken to this page once you logged in, and then you want to go to the API key page. And so for here, you'll be able to create new API keys, and you could create several API keys for your different projects. And then you could copy the API key here. And so we're going to generate. So next you want to type in VI, and then, like followed by the tilde, which will be the current working directory, and then type in /bash_profile. This will take you to the script. However, as this will review all of the other, like dependencies that your computer operating system is working on, it might have sensitive information. So I'm not going to run that, but you can go ahead and, hit on enter. And then the next thing that you want to do is go to the new line at the bottom of the script of the bash profile file. And then you want to type in export replicate API token equal, and then, like the API token that you've copied, which might be similar to like this. So this is for replicate, and then you could hit on enter, right? Hit on enter, or not enter, but, copy paste that into the bash profile. And then another line, you want to type in also export, and then assembly AI API key, and then the API key that you've copied from assembly AI. And then you want to make sure that you have these both lines in your bash profile. Or you could even, just type this into the command line every time you want to run your script. However, it will lose memory, but if you put it into your bash profile, it will retain that memory whenever your terminal or command line loads up. That will be extra convenient. So once you have your API token in your bash profile, which will allow it to persist, whenever you want to run it, you could just type source and then tilde / and then bash profile. It will literally, activate the file, and your API key or token will be in memory. Now, in order to install other dependencies, you want to now, because you already have Ollama installed and you have already downloaded Ollama, you want to now make sure to have Brew installed on your computer. If you don't already have Brew, you can go to brew.sh and, copy paste this into your command line to install it. And once you install it, you can install Port, which is a package that will allow you to essentially handle audio. So you could type in brew and then install ports audio. Okay, so I already have that installed, so I'm not going to worry about that. So you could type in exactly here, brew install port audio, and that will allow you to have support for audio handling in the command line. And if you have issue installing Brew install port audio, what you could do is install Brew, as I already mentioned. But for the next part, you might want to have Xcode install. So you could type in Xcode -select and then -install -install. So this will allow you to have the ability to compile code in the command line for your Mac OS. Okay, so if you have Linux, no worries, you already have the support for that. So make sure to type that if you need to have support for compiling code, which you'll need for the next step, which is to do pip install, okay? But before pip install, we're gonna create the conda environment. So we're gonna do like conda create -n for new, and then the name of the environment. So I have already created assembly AI. So let's say you want to do something like AAI, and then you could specify the version of Python you want to have installed. I'm doing 3.12, hit on enter, and then it will perform the installation. It will ask you if you want to have the following libraries installed. Press yes or capital Y, hit on enter, and then it will install the necessary dependencies. Then we're going to do pip install assembly AI extras. It has already installed that. Oh, okay. So I'm already in the assembly AI version of it. But yeah, it's the same concept. Next is to pip install Olama, and then you can hit on enter. But I already have it, so I just do this. Pip install replicate, and then pip install sound file. All right, and then pip install sound device. Okay. I'll also provide you with instructions on how you could just copy paste that into your command line, and that will be super easy on your part. And that's about it. That's how you can install your environment or set up your environment. And once you have already done so, whenever you open up your terminal, type in conda activate, and then your environment name, and then source, and then Python voice agent. And that's it. Power off. Okay, so it has detected that I mentioned power off. But yeah, you get the concept. So whenever you type in Python and then the voice agent, it will power on. And whenever you want to exit, just say power off and it will exit the script. So yeah, that's about it. And there's several more use cases that you could do with this as your template. You could change the audio, the voice. You could change the voice. You could adjust the parameter for the silent period when you are, or articulating or thinking, and it would do the partial transcript. There are parameters for you, as I have already mentioned, and you could change the prompt, and this will, you could create different use case for that. You could have a learning assistant for English language. You could have a learning assistant for learning how to code, a Python coach, or data science coach. And I mean, the possibilities are endless. You could change the large language model and see how it generates the different responses. And yeah, let me know in the comment section down below how you're modifying this particular voice agent. And I'd love to hear all of your comments. Thanks for watching until the end of the video. If you reached this far, please drop a star emoji so that I know that you're the real one. And don't forget to like, subscribe, and hit on that notification bell. And as always, the best way to learn is to do. And I'll see you in the next video.